Aera is an exercise physiologist who lives with HEDS. She graduated from Mount Royal University with a Bachelor of Science in Biology, concentrating on anatomy and physiology. And she's currently a graduate student in the Faculty of Kinesiology. And it looks like she's still setting up. So let me launch our next poll. Take your time. Once again, it didn't work.
Okay.
We'll let you take over. Let me get this back on PowerPoint for you.
All right.
We'll get this figured out eventually. All right. So I'll let you take it away. Aera is going to be speaking today about the high cost of every step, how hypermobility affects pain, strength, and fatigue during walking.
Hi, everyone. Like Dr. Minocha said, I'm Aera, and I'm here to present to you original research that was done with your community support. These are results from Calgary, people in Calgary living with hypermobility. So I think at this point of the day, we're all pretty aware of what hypermobility spectrum disorder and hypermobile Ehlers-Danlos syndrome are, but I'm just going to do a quick overview. Hypermobility occurs in approximately 10% of the population. Hypermobile Ehlers-Danlos syndrome, HEDS, and hypermobility spectrum disorder, HSD, share many symptoms. But HEDS has stricter diagnostic criteria, while HSD is diagnosed when somebody has symptomatic hypermobility but does not meet the full HEDS criteria. But the current evidence suggests that they likely exist on a phenotypic continuum, not entirely as separate diseases. So this means that the biochemical basis is thought to be the same, but the way it presents is different in every person. And this is not a linear spectrum. And so what this means for the research I'm going to present to you today, well, some of these symptoms are muscle dysfunction, autonomic dysfunction, the lack of connective tissue, and a lack of proprioception. And this all drives chronic fatigue. And this chronic fatigue leads to people not wanting to do as much physical exertion because it's exhausting, it hurts, and this is kinesiophobia develops because they're getting injured. And this leads to a deconditioning of the muscles. And this deconditioning of the muscles further contributes to microtraumata such as sprains and strains, and which leads to pains in the joints. And all of this is just going to feed into itself. And this is eventually going to create this downward spiral. But us and other researchers have proposed that some daily exercises, and like we heard before, this could be as simple as moving your tongue in your mouth, but it has to be individualized. But this may help stop or at least slow down this downward spiral that occurs. Sorry, I don't know how to use this clicker. And anyway, that's just the background of kind of the purpose of the study. And so this was a larger study. I'm just talking about one aspect of it. And this is to investigate the qualitative factors that may contribute to exercise intolerance in the hypermobile population. So these are self-reported symptoms by the participants themselves, and how we can use that to maybe potentially inform exercise prescription in the future. So this is the whole setup. We had like people wearing this mask, and this was indirect telemetry for cost of transport. So basically the metabolism of what's occurring. We had EMGs on them, we had ultrasound. But today we're just kind of talking about the qualitative aspect of that. So we used 3 well-validated and widely used questionnaires. And these were sent to the participants before they came in for the walking trial. And these were the SF-36, which is a quality of life index, this fatigue severity scale, self-reported fatigue, and the foot function index, which is self-reported pain, foot pain and function. And we used the visual analog scale, which is basically like a line, and the participants like marked off on the line. It doesn't have numbers on it. How much pain they had before and after walking trials. And then we also looked at the cost of transport. The 3 trials were at 80%, 100%, and 120% of the preferred walking speed, which we determined before the walking trial. And we compared all of our hypermobile participants to healthy age-matched controls. Criteria for the hypermobile patients were either clinically diagnosed with HEDS or scored greater than 5 on the Baton scale. And this is what we found. So this is the SF-36 data. I'll just orient you to it. The closer somebody is to 100 on this scale, basically like the better their physical functioning is. So you can see that in the gray is the HEDS and the black is the controls. Across the board, the hypermobile group scored lower in every domain except for in general health. So the participants reported that their general health was not necessarily different than the controls. And then for the fatigue severity scale, the hypermobile group showed higher fatigue severity when compared to controls. Some really interesting questions here were, fatigue is among my most disabling symptoms. Fatigue interferes with daily life things like work, family, social, carrying out responsibilities, sustained physical functioning, interfering with my physical functioning. And also, I'm easily fatigued. Exercise brings on my fatigue. The only thing that wasn't different, my motivation is lower when I'm fatigued. I think we all can agree that everyone's motivation is lower when they're fatigued, so that was not a very surprising finding. This one, lots of questions. I'll point out some relevant ones, but this is from the Foot Function Index. So the hypermobile group reported higher foot pain when compared to controls, which is something really important when you're walking if you have a lot of foot pain. How much pain or stiffness do you have when you're walking? How severe is your pain when you're running or fast walking? And how often have you limited your physical activities? Those were very, very different between the two groups. And then what I thought was really interesting is that the control group basically reported never using assistive devices, never reported using braces, but the hypermobile group did. In terms of the pain through the VAS, the hypermobile group reported higher pain at all walking speeds. In the black is the control. They basically reported almost no pain with a little bit of variability, whereas we had a participant at 80% who was almost at a 7.5 out of 10 on the pain scale, right? So pretty severe pain for walking, something we need to be considering when we're telling people just to get out and walk more. In terms of cost of transport, the hypermobile group had a higher cost of transport, so we know that they are actually using more energy to do the same amount of work, basically, as the control group. So across the board, across at 80%, 100%, and 120% of preferred walking speed. And then finally, we did some correlation analysis. So this graph basically is saying that from the physical functioning from the SF-36, the quality of life index, body pain from the SF-36, and energy and fatigue from the SF-36, as well as VAS from that's that pain scale. So for physical functioning and body pain, these things are positively correlated. The higher your physical functioning, the less body pain you have. In terms of energy and fatigue, the higher your physical functioning, the lower your fatigue and the less lower your fatigue and the higher your energy. And then for the visual analog scale, this was negatively correlated. So the lower your physical functioning, the higher your pain was following walking trials. And so in conclusion, our hypermobile group basically scored lower in every aspect compared to controls except for the general health from the SF-36 and motivation from the fatigue severity scale. And so we inferred that as physical functioning declines, pain following walking increases. Cost of transport was significantly higher in the hypermobile population. Quality in life and pain are important considerations when prescribing exercise. But this physical conditioning is very important for preventing that downward spiral that results from kinesiophobia and movement avoidance. So the next steps would be to investigate exercise interventions for the hypermobile population that will strengthen joints and decrease joint instability, and also for clinicians to consider quality of life and pain and work with your patients when you are prescribing these things. And there's 3 papers published from this study. I think they're on the Better Mobility table out there, but if you have any questions or you want these papers, I'll send them to you. So just email me at aera.ladell@ucalgary.ca. Thanks.